Hi, in this video we're going to learn how to multiply and divide radicals. At the end of the video, you are expected to be able to perform multiplication and division of radicals. Let's begin with multiplication. When you multiply radicals, you just multiply coefficient to a coefficient and then multiply radicands to a radicands. You do not multiply a coefficient with a radicands. Radicands are the numbers inside the radical symbol. Coefficient is the number outside and in front of the radical symbol. And then check the value inside your radical if it is possible to simplify. It may be that it is a perfect number, or a factor of that number is a perfect number. Always refer to your power table. Let's have a review of your properties. First property in your simplifying of radicals says square root of a times square root of b is equal to multiplying a times b. This is actually the reverse of the factoring that you learned in your simplifying. This will only be possible, remember, if a and b are greater than or equal to 0, because negative creates an imaginary number. Let's test the property. What if you multiply 9 times 16? 9 times 16 is 144. 144 is a perfect square with a square root of 12. What if you just perform the square root of 9 and square root of 16? You have 3 and 4. 3 times 4 is 12. This is to show that either of the method is possible, but it all depends on the problem. Just make sure you don't violate your math property. Next, another property that you need to remember: if you have this expression square of the square root of a number, it's actually whatever happens is equal to the value inside. This only works for square root. It does not work for other powers. So whatever happens, whatever you see inside is equal to that number inside. A square of a number with a square root, or the square root of a number and then squared, is equal to that number. Just always remember that. You will need it later. Next, now, how do you actually multiply? According to the rules, you multiply a outside the radical together, which is your coefficient. Here we have 1 times 5. Afterwards, we multiply the radicals, which is 12 times 3. 12 times 3 is 36. There's no number, it presumes 1. 1 times 5 is 5. Now, 36 is a perfect square, which is 6. And therefore, we were able to simplify the expression or the problem. 5 times 6 is 30. That's it. Let's have some more. 6 square root of 5 times square root of 8. You just have 6 times 1. 6, 5 times 8, 40. 40 can be factored into 4 times 10. There's no other way. We chose 4 because 4 is a perfect square, and we can extract square root from it, which is 2, which will be 6 times 2. 6 times 2 is 12. And that's basically how you do a regular multiplying of radicals. Let's have some more examples. 5 times the square root of 35, you have 175. What you can do is simplify this by factoring. You have 25. Divide the whole expression by 25, you actually get 7. 25 times 7 is 175, and square root of 25 is 5. Next, 2 times the square root of 8 times 3 square root of 7. Now this time there's actually numbers and radicals. You just multiply 2 times 3, 6. 8 times 7, 56. 56 can be factored by 16. No, 4. 4 times 14 is 56. 4 can be simplified into 2 by taking the square root, and only 14 remains inside the radical. So you have a 6 times 2, 12. 12 times the square root of 14 is the final answer. Let's have some more. Here you have 2 times the square root of 5 times 4 times the square root of 20. 2 times 4 is 8. 5 times 20 is 100, but it's a square root of 100. But 100 is a perfect square, 10 times 10. Therefore, it's 20 times 10, which is 200. That's it. That's how you simplify. It's supposed to be easy. Okay? Just remember, if there's variable, then you just multiply a variable to a variable, a number outside to a number outside, or a variable outside to a variable outside. Okay? Inside to inside, outside to outside. That's how you you multiply radical expressions. Now, what if you have two terms multiplied to a one-term radical? You just perform a distributive property. If there is two terms times two terms, then you will perform FOIL. It will be on the third example. We will do FOIL. So by distributive, you just pair it up. First and the first, square root of 3 times 7. You just write them together. 7 comes first before the radical. Second distribution, remember, a square root of a number times the square root of a number is equal to the number. Therefore, it's 3. That was the shortcut which I explained in the previous page. And it's done. Let's have another example. Just the same, distributive property. The first result will be 5 times the square root of 2. The next one, you are going to multiply your radicands. Radical times a number, you write them together, wherein number comes first. But radical to a radical, you multiply. This one is actually square root of 3 times the square root of 3 is actually square root of 9, which is actually 3. That's another way of solving it. Here you have 2 times the square root of 2 times the square root of 8 is actually square root of 16. But the square root of 16 is 4. Don't forget your minus. So you just simplify 16. And now this is your FOIL. If you have two numbers times two numbers, perform FOIL. First is 36 by the first, and then O outside, 6 times the square root of 2. You just write them together, but it's negative. And then the inner, square root of 2 times 6, positive. And then the last, remember, square root of 2 times the square root of 2 is the number. It will be negative because of the negative sign, so it's minus 2. Amazingly, it's negative 6 square root of 2 plus 6 square root of 2. It will be cancelled out, but you need to copy your 36 first. Cancel. Minus 2. Amazingly, the problem is just a one number result. 36 minus 2 is 34. This cancellation is only possible if the first terms are the same and then the second terms are the same, but one is plus, one is minus. If it does not follow this format, this cancellation is not possible. There are results when you combine like terms here, which will be another example on the next page. Let's deal with it right now. Let's proceed. A simple distributive property. You try now. The answer is 2 times the square root of 5 plus 5. Next, the square of the expression 2 plus square root of 5. It means you multiply it to itself. Perform FOIL. 2 times 2, 4. 2 times the square root of 5 is 2 square root of 5, and then the inner, another 2 plus 2 square root of 5, and then square root of 5 times square root of 5 is 5. And then combine like terms. 4 plus 5 is 9, and then 2 plus 2, 4 square root of 5. And that's the answer. That's the final answer. Now, again, this was the format I was talking about. If you noticed already ahead, you don't need to do the complete FOIL. the inner and the outer will be cancelled out. So what you only have is the first. You have 25, 5 times 5, and then square root of 7 times the square root of 7 is 7, and it's a minus sign, minus 7. But you can actually perform subtraction. 25 minus 7 is 18. That's how you perform multiplication of radicals. Okay? How do you do division? When you divide the coefficient to a coefficient, and then divide radicands to radicands. No switching, no switch pair, coefficient to coefficient, radicand to radicand. And if possible, you need to rationalize. When you say rationalize, the denominator will be not radical. Let's have example. This is the property as a review. Square root of a plus b is the same as square root of a divided by square root of b. Let's show that this is true, but on the conditions that a and b is not negative. By following the right side, we will separate. Square root of 64 is 8, square root of 16 is 4. 8 divided by 4 is 2. But if you notice, it's possible to simplify or divide, and there is no remainder, then you may also do that way, like directly dividing a divided by b. 64 divided by 16 is actually 4. But it's a square root of 4. Square root of 4 is 2. This just shows that either of the method is possible. You divide first before square root, or separate the square root and then simplify. Sometimes only one works, sometimes both works. Let's have another sets. Now it's the example. Letter A, is it possible to simplify? 5 divided by 10? I don't think so. There is nothing to simplify because the square root is simplified and every term in the fraction cannot be divided by 10. A is done. There's no way we can simplify it, or there's no way that we can divide it. But B, we can. But first, we need to simplify a radical. On the problem 4 plus square root of 12, square root of 12 divided by 2, square root of 12 is possible for simplifying, which is factor square root of 12, which is 4 times 3. Square root of 4 times 3. Square root of 4 is 2. Now, you can actually divide 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So, 1 comes with the square root of 3 or just the square root of 3. That's how easy it is. If your problem looks like this. If your problem looks like this, it's just a lot of work on the simplifying. You're going to figure out what factors of 180 is a perfect square. Well, to show, it's actually 36 times 5. Square root of 36 is 6. And now here's the tricky part. We can factor out 3 on each term. Factor out 3 from 15 is 5. Factor out 3 from 6, it's 2. And so we can cancel. 9 is 3 times 3. We can cancel now 3 and 3. And so what is not cancelled is your final answer. But here's the tricky. Here's another way of looking at it. Divide by 3, 5. 6 divided by 3, 2. 9 divided by 3, 3. That's another way of simplifying fraction by dividing an integer to everything. But it should be the same for all. Or factoring and cancellation is another way of simplifying. It's a lot of property. Let's have some more examples. Now, the problem comes on your previous slide. There is no radical. Problem arises if there is a radical on your denominator. How do you simplify? Well, a simplified fraction has no radicals in the denominator, so this is not considered simplified. How do you Simplify. Well, denominators must be rationalized. How? You multiply the expression by 1, but 1 is not going to change the whole thing. But we can transform 1 to a square root of a number over square root of a number. What number do we use? The number in the denominator under the radical sign. So here is your rationalizing. That's how you do rationalizing. You're going to multiply a fraction of the square root of a number over square root of a number based on your square root of the number in the denominator. How does this work? Remember, when you multiply 2 times the square root of 3, you just copy. But square root of 3 times the square root of 3 is 9. Square root of 9 is 3. Or as a shortcut, it's equal to 3. And it's actually done. That's how rationalizing is done. Rationalizing is saying you need to find a way that there is no radical in your denominator. And this is already rationalized. We were able to do it by multiplying the given fraction by the square root of a number over square root of a number, which is the value of your radical, the square root of a number. Let's have another example. So here, instead of square root of 3, we are going to multiply the expression by square root of 5 times the square root of 5. And so, on top, you have 15 times the square root of 5. Underneath, you have 5. But 15 is divisible by 5, which is 3. And so, our answer is just 3 square root of 5. It's a little tricky. You just need to watch out if there's still possible to simplify. It's either you can simplify the radicals because there's a factor of a power number based on the roots, or the coefficients are possible to simplify. Okay, now there is what you call conjugate. You will understand why do we need, or what is conjugate. Conjugate is if the given expression is x plus y. Conjugate is just a change of sign. If you are going to multiply expression in the conjugate, remember this was the pattern a while ago. On FOIL only there is only first and the last result. The outside and the inside cancels out. That's why there's first and last. As an example, if you have 2 plus the square root of 5, when you conjugate, you just change the sign. When you multiply, you have 2 times 2, 4. Square root of 5 times square root of times negative of square root of 5 is going to be negative 5. So you have 4 minus 5. And 4 minus 5 is negative 1. Another, 10 minus the square root of 2 is change of sign. 10 times 10 is 100. Square root of 2 times the square root of 2 is 2. So 100 minus 2. It's 98. Another, square root of 10 plus 6 times the conjugate, just a minus. So conjugate is when the given is plus, the conjugate is minus. If the given is minus, the conjugate is plus. It's just switching sign. Here you have 10 minus 36, and it's negative 26. What you need to notice is that conjugate enables us to make the radical symbol go away mathematically. What do we need? Why do we need conjugate? Well, if your given has a denominator of a radical, the method a while ago, which is multiplying a square root of a number times a square root of a number, will not work anymore. This is where we apply conjugate. We will multiply conjugate over conjugate. What's the conjugate? Copy your denominator and then change sign, and then you multiply it on top and below. Why is this possible? This whole conjugate over conjugate is equal to 1. Why did we make it complicated? This is the only way that the radical in the denominator will disappear. That is rationalizing. We will rationalize this by getting rid of the radical by multiplying conjugate over conjugate. of the denominator. Let me show you how the work goes. When you multiply 2 times 5, 10, 2 times negative square root of 3, you just write 2 times square root of 3, but it's a minus. Underneath, 5 times 5 is 25, square root of 3 times square root of, but it's negative, square root of 3 times negative square root of 3 is negative 3. 25 minus 3 is 22. We were able to get rid of the radical. This is still possible to simplify. Divide everything by 2. And you get 5 minus square root of 3 over 11 by dividing everything. This is the cancellation method instead of factoring and then cancel the factors. What's the whole deal with this? Well, by conjugate method, there is no more radical in the denominator, and so therefore this is considered simplified form. When you are dividing radicals, you don't actually divide. You do conjugate over conjugate multiplication or square root of x times the square root of x multiplication. Let's have some more examples. What do? Square root of x times the square root of x, which is square root of 2 times the square root of 2. This becomes 6 square root of 2 all over 2. 6 divided by 2 is 3. So that's it. Square root of 3 over 2. Next, we are going to find the simplified form, the square root of 5 times the square root of 5. This becomes 5 times the square root of 5 all over 5. Cancel, and what you have left is the square root of 5. Erase, and that's your multiplying x, square root of x over square root of x. Now we need to conjugate. Oh no, we are going to multiply. Instead of dividing, we are rationalizing using the conjugation. Change the sign. And then perform your distributive property. 8 plus square root of 3. 2 times 2, 4. There is no outside and inside, so it's only square of the first and square of the last. Minus 3. Since it's 4 minus 3, it becomes 1. It just cancels because it's, let me just leave it there. And so since it's equal to 1, the whole thing is equal to 1. So it's just 8 plus square root of 3. And that's it. By conjugation, there is no more denominator. We were able to eradicate the square root of 3 under. Okay? You may want to watch the video again so that you can perform your division and multiplication of radicals on your exercises. Thank you.